Hello students, let's start with a new topic, rational numbers. Yes, altogether new concept of rational numbers. So let's quickly first define what are rational numbers. So if I want to define rational numbers, so in easy words I will say any number which can be expressed as any number which can be expressed as a upon b, which can be expressed as a upon b, that is fraction. It's a fraction, a upon b, that is fraction of whom? That is fraction of two integers. Any number which can be expressed as a upon b, in the form of a upon b, that is fraction. It's a fraction. This is a fraction, a upon b. Fraction of whom? Of two integers. This a upon b should be integers. Then that fraction or that number is called as a rational number. Okay, so once again let's repeat. Any fraction of two integers, a is an integer, b is an integer, is called as a rational number. But we have one exception. Before explaining that exception, I'll write here this is my numerator and this is my denominator. Of course, the numerator should be an integer, and denominator should also be an integer. Okay. Now, who all can come in numerator? In numerator, any positive integer, all the positive integers can come. Any positive integer, even 0 can come in the numerator, and all the negative integers can come in the numerator. And in the denominator we have an exception. In the denominator there can be all the positive integers and all the negative integers, but the denominator should not be equal to 0. Denominator में 0 नहीं आ सकता है. Numerator में any positive integer can come, any negative integer can come, even 0 can come in the numerator, but in the denominator only positive and negative integers can come, but the denominator के अंदर 0 नहीं आ सकता है. Denominator cannot be equal to 0, because if in any fraction, if denominator is equal to 0, if by chance, then that fraction or that number is not defined. Let's take some examples to understand in better way. Example, 7 upon 5. Can you compare with this a upon b with 7 upon 5? Can I say at the place of a I have 7, at the place of b I have 5? So students, will you say that 7 upon 5 is a rational number? Yes, of course, it's a rational number. 7 is an integer, 5 is an integer, so it's a fraction. So of course it's a rational number. Yes, 7 upon 5 is a rational number. Next, minus 9 upon 6. Is this a rational number? Yes, minus 9, although it's a negative, but all positive, all negative numbers, and even 0 is included in the numerator value. So negative integer in the numerator and the 6 in the denominator is a positive integer. Of course it's a rational number. Now one more example, students. Minus 3. If I write only minus 3, is this a rational number? Now you will be confused a little bit. You will say, sir, you told us that there should be a fraction, there should be something in the denominator at the place of b, but here we don't have anything, so this is not a rational number. But then I will say, no students, no. Anytime in the denominator I can put 1. So minus 3, of course it's an integer, and 1 is also an integer. So minus 3 upon 1 is also a rational number. So even if they give you only minus 3, so by default when nothing is mentioned in the denominator, it's always 1. So just consider in that aspect, and we can say minus 3 is also a rational number, because in our submind it should be like it is divided by 1. Similarly, if only 7 comes, only 7, so in your submind it should be the case that we can anytime write divided by 1. So this is also an integer, this is also an integer. So 7 upon 1 is a fraction of two integers. So 7 upon 1 is a rational number, or even I can say 7 is a rational number. Okay. Can I say, students, 0? Is 0 a rational number? Now, as I did in this case, it was -3, so I wrote upon 1 from my side. Same in this case, I told we can anytime write upon 1. Similarly, I can write here upon 1. Can I say, students, 0 is an integer? Yes, 0 is an integer, and upon 1 I write from my side, because any number can be written upon 1. 0 is an integer, 1 is also an integer. So can I say this also fits in our case, a integer, 0 is an integer, and I wrote over here that numerator, in the numerator where we have here 0, numerator can have all the positive integers, can have all the negative integers, even numerator can have 0. But we have exception in the denominator. Denominator should not be equal to 0. So here denominator is 1. It's not equal to 0. So 0 upon 1 is also a rational number. Is also a rational number. Understanding, students? This is also a rational number. Okay, now let's take more examples. Of course, so only if 0 is given, then we can say it's a rational number, because anytime we can apply divide by 1. So this is the logic why only 0 is a rational number. Okay. Now let's take another case, students. Now if I say -5, or if I take only 5 upon 0, is 5 upon 0 a rational number? Now students, tell me, if I compare this in the form of a by b, can I say this a, at the place of a I have 5, it's a numerator. Is it an integer? Yes, it's an integer. It's a integer. Okay. Now if I say this 0 is at the place of b, which is a denominator, d for denominator. So now tell me whether this 0, the 0 can come in my denominator? No, it's clearly mentioned, I have marked a star over here, that in a rational number, whenever we have a fraction, denominator can have all the positive values, all the negative values, but denominator should not have 0. But here we have 0. So 5 upon 0, although 5 is an integer, although 0 is also an integer, but the rule says that any number to become a rational number, the denominator should not be equal to 0. So 5 upon 0 is not a rational number. It's not a rational number. Why? The reason is, in maths, if any number 5 upon 0, or suppose I have 1 lakh upon 0, 2 lakh upon 0, any number is divided by 0, that is, whenever 0 comes in the denominator, that number is not defined, that number is undefined, and also it's called as infinity in maths. Okay, so hope you understood the logic, students. Please proceed with this. So starting with the first exercise of this chapter, rational numbers, exercise 4.1, question number 1, the heading is rewrite the following rational numbers in simplest or standard form. In simplest or standard form. In question number 1, I'll start with the sub-question B. The question is -189 upon 216. This is my question. Okay, so -189 upon 216. We just have to write it in the simplest form or the standard form. In other words, I just have to reduce it. Okay, so if I have to reduce it, I'll first start with 2. Is it possible to divide with 2? Here I can see 6 is an even number, so this 216 can be divided by 2. But this 189 cannot be divided by 2 because I have an odd number 9. Okay, so students, will both the numbers be divided by 3? I don't know. Let's check. See this method of checking. All of you pay attention how to check when a 3-digit number or a 4-digit big number, it is divided by 3 or not. Please see the shortcut, the trick of checking. Add all the numbers. Here I have 1. Add all the digits. 1 plus 8, it is 9. 9 plus 9, 18. Does 18 goes in 3 times table? Yes. So if 18 goes in 3 times table, that means 189 will also go in 3 times table. Similarly, let's add the digits of denominator. 2 plus 1, 3. 3 plus 6, 9. Does 9 goes in 3 times table? Yes. So because 9 goes in 3 times table, so 216 will also go in 3 times table. So 3 6 are 18, 3 3s are 9, 3 7s are 21, 3 2s are 6. Once again, 6 plus 3 is 9. 9 goes in 3 times table, so 63 will also go. 7 plus 2 is 9. 9 goes in 3 times table, so 72 will also go in 3 times table. So 3 2s are, 3 1s are. Here 3 2s are 6, 3 4s are 12, 3 7s are 21, 3 8s are 24. So my answer is 7 upon 8. 7 upon 8. Alright, students, don't forget this. We have minus sign over here. It's minus 189. This happens. It's a very common mistake. So we have to apply minus also over here. Okay, the answer is minus 7 upon 8. Answer of a first question on the board. Now let's proceed with another question. Another question on the board. It's sub question C. The question is same, right, in the standard form, and the question is minus 315 upon minus 343. This is my question. Minus 315 upon minus 343. We have to write in the standard form or the simplest form. Okay, so what I will do, first thing I'll just copy the question, minus 315 upon minus 343. Can I say, students, this minus minus cancels, so now my answer will be positive. Okay, now let's solve. Now students, once again I can see we have odd numbers 5 and 3, so it will not go by 2. Let's check with 3. Let's add the digits. 3 plus 1 4, 4 plus 5 9. Yes, 9 goes in 3, so 315 will also go in 3 times table. Once again over here, 3 plus 4 is 7, 7 plus 3 is 10. 10 does not go in 3 times table, so 343 will not go in 3 times table. That means I cannot reduce it by 3. So now by which times table? It cannot go by 2 even number. It is not going by 3. It will not go by 5. Let's try with 7. So 7 4s are, it's 28. So carry over 3 here. 7 5s are 35. 7 4s are is 28. So carry over 6 years. It becomes 63. 7 9s are 63. So it comes to be 45 upon 49. And I don't think so we can reduce it to much more extent. So answer is 45 upon 49. Of course the answer will be positive because minus minus gets cancelled out. Okay, now moving on to the next question, students. It is sub question G. The question says it's 12 upon minus 42. Okay, so first let's copy the question. 12 upon minus 42. Okay, students, now you all tell me how to proceed with. I can say both are even numbers, so let's start with 2. 2 6 are 12, 2 2s are 4, 2 1s are. Okay, once again I can say this, both the numbers goes in 3. 3 2s are 6, 3 7s are 21. Yes, and don't forget this minus sign, and minus sign is in the denominator, so you can write 2 upon minus 7. This can be one of your answers. Okay, let me write properly. 2 upon minus 7. This can be one of your answers. Or even your answer can be minus 2 upon 7. Or even your answer can be minus 2 upon 7. Minus you can write at the center. This is also a correct answer. So students, what you understood from this last example, that minus, if it's in the denominator, you can put in the denominator. But it's fine if you put the minus in the numerator also. Also it's fine if you write the minus sign at the center like this. Hope you understood. Please pause the video and start doing it. Now we have question number 2 on the board. Write 5 more rational numbers in each of the following patterns. We have to write more 5 rational numbers according to the pattern given. Okay, so starting with the first sub question A over here, minus 2 upon 7, comma, minus 4 upon 14, comma, minus 6 upon 21. minus 2 upon 7, comma, minus 4 upon 14, comma, minus 6 upon 21. We have to observe this pattern, this sequence given to us, and write 5 more rational numbers. Okay, so I'll say I have to add on 5 more rational numbers. So the easiest way is, first of all, I'll write the numbers afterwards, but can I say I can first make the empty boxes 1, 2, 3, 4 and 5 upon sign also. Okay, I can do this much. I have to add more 5 rational numbers. Of course there will be commas in between them. It's a continuation from here. Okay, if I closely observe, students please pay attention, if I closely observe, I'm observing first just the denominators. Mark my words, I'm observing the denominators. Here I have 7, then I have 14, then I have 21. Oh my god, can I say this is 7 times table? 7 ones are 7, 7 twos are 14, 7 threes are 21. So 7 fours are will be 28, 7 fives are will be 35. It's a 7 times table. 7, 14, 21, 28, 35, then comes 42, then comes 49, and then comes 56. Great, great. Okay, one more thing, if I observe carefully, students, in the 3 terms or 3 elements of a sequence or a pattern given to us, there is minus sign on all the numerators. So that means this entire sequence is negative. So minus sign, minus sign, minus sign, minus sign, minus sign. See how I am proceeding with. Okay, then if I observe, see this, if you see here, I have here 2, I have here 4, I have here 6. Can I say, students, it's a 2 times table? 2, 4, 6, then 8, 10, and it goes on. So can I say here 2, sorry, it's given here 2. So 2, 4, 6, 2 ones are 2, 2 twos are 4, 2 threes are 6, 2 fours are 8. It's 2 times table. 2, 4, 6. So here 8 will come, here 10 will come, here 12 will come, here 14 will come, and here 16 will come. 8, 10, 12, 14 and 16. So this is my answer. I have added 5 more rational numbers as per the given pattern. Hope you understood, students. Please copy it. Similar type of question, the same thing, write 5 more rational numbers in question number 2. The next question I will write is sub-question D. Sub-question D. The pattern given is, or the sequence given is 15 upon 8, comma, minus 30 upon minus 16, okay, comma, 45 upon 24, comma, dot dot dot. Okay, there's 3 dots over here. That means it goes on, and of course we need to find more 5 numbers after this, more 5 rational numbers. So the question is, they have given to us 3 terms, 3 elements of a sequence, first, second, third. We have to write more 5 by observing carefully these 3 rational numbers or these 3 elements. Okay, so now I have to add on more 5 elements, right? So once again, 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Upon, comma, 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 comma. Okay. Okay. Now let's observe carefully, students. Let's observe carefully. I can see over here, students. Now I'm talking about numerator. Mark my words. Listen carefully. I'm talking about numerator. Numerator first we have here plus, in plus. Then I have in minus. And now once again I have here in plus. So can I say in numerator, I mark my words, I say in numerator, it starts with plus, then minus, then plus. So of course then minus will come. So plus, minus, plus, minus, plus, minus, plus, minus. Now let's see about the denominators. In the denominator I have plus over here, plus. So here comes minus. Then once again I have plus here. Nothing is mentioned, means it's by default plus. Nothing is mentioned in front of it means it's a plus. So plus minus plus, the next will be minus plus minus plus minus. There can be a doubt in your mind, sir, this minus minus cancels. I know it cancels. I know this fraction becomes positive. But when we are writing the sequence pattern based on this, so we have to write, we have to follow what they have written. Eventually I know the net effect will be positive. Here also the net effect will be positive, minus minus cancels, but we have to follow the pattern like this. Okay, now let's concentrate only on the numerator. All of you, let's concentrate only on the numerator. Here I have 15, here I have 30, here I have 45. Can I say it's 15 times table? 15 ones are 15, 15 twos are 30, 15 threes are 45. Yes, it's a 15 times table. So 15, 30, 45. Then comes 60. Okay, then comes 75. Then comes 90. Then comes 105. Okay, and then comes 120. Okay, now if you closely observe this denominators, 8, 16, 24, it's 8 times table. 8 ones are 8, 8 twos are 16, 8 threes are 24, 8 fours are 32, 8 fives are 40, 8, 16, 24, 32, sorry, here 40 will come, 40, 48, then one more 8, 56, 64. So 32, 40, 48, 56, 64. Hope you understood, students, how to write the patterns. Please pause the video and write by yourself, by your own. Students, now the next question, the main heading, question number 3, give 5 rational numbers, equivalent to. That means now they will give us one rational number. Let's take quickly one of the sums. Sub question B, it's given here minus 42 upon 18. This is a rational number. So we have to write 5 more rational numbers which are equivalent to this minus 42 upon 18. Okay, and believe me students, what 5? You can write hundreds of rational numbers which are eventually equal to or same to as this given rational number or equivalent to this given rational number. How to do it? See here, first I'll copy once again, minus 42 upon 18. This is my question. I have to write 5 rational numbers which are equivalent to this minus 42 upon 18. For the first case, let's leave this minus as it is outside. The first step is, students, pay attention, just reduce it to the lowest aspect. Can I say it goes with 2? Yes. So 2 2s are 4, 2 1s are 2 9s are 18. Once more I can divide, students, it by 3. So 3 7s are 3 3s are. So can I say, students, the lowest form which I get is 7 here and here 3. So what I got, students, I'll just write here. The lowest form which I got over here is minus 7 upon 3. Okay. So after solving, I got the lowest form as minus 7 upon 3. So students, can I say this minus 7 upon 3 can be one of my rational numbers? Yes. Because when I reduced it, when I brought it to the simplest form, I got minus 7 upon 3. So one of the rational number equivalent to or equal to minus 42 upon 18 is minus 7 upon 3. Great. So can I say, students, my first rational number over here is minus 7 upon 3. Okay, it's done. Now, how to find the second rational number? So to find the second rational number, what I will do, in my submind, this is the calculation you should do in your submind, I'll just multiply 2 in numerator as well as in the denominator. See, once again I repeat, when I reduced it in the simplest form, minus 7 upon 3 is my first rational number. I got it. Now I want to bring more 4 rational numbers. So always start your solution from the reduced one which you achieved over here. So I just wrote minus 7 upon 3 over here. I'll multiply 2 in the numerator as well as in the denominator. So tell me what will happen. So 2 into 7, it comes to 14, and 3 2s are 6, and minus remains as it is. So this will be my second rational number, students. So understood? See, please see here. So how I'm getting other rational numbers? I'm starting my solution with the reduced form. Reduced form itself is my first rational number. Then I just multiply 2 with numerator and denominator. I got the second one. Okay. Once again, students, once again, I'll take the help of the reduced one. It's what? Minus 7 upon 3. Okay. Now in my submind, I'll multiply. First I multiply with 2, 2. Now I'll multiply with 3, 3 in my submind. Both in the numerator as well as in the denominator. 7 3s is 21 and 3 3s is 9 and minus remains as it is. So students, now I can say this is my third rational number. Understanding, students? This is my third rational number. So I started with minus 7 upon 3. It itself is the first rational number. Then I multiplied 2 with numerator and denominator. I got the second. Then the same minus 7 upon 3 I multiplied by 3 3. I got the third rational number. Now students, I'll once again take this minus 7 upon 3, my reduced form, and now I'll multiply. First I'll with 2, then 3, then I'll multiply with 4 in my submind. Okay, so 7 4s is 28. 28 upon 4 3s is 12 and minus remains as it is. So students, now also I got the fourth rational number. It's so simple. Always start with the reduced form. Okay, so first, second, third, fourth I got. Okay, now what to do? Now I'll do the fifth one. Fifth rational number. Once again I start with this minus 7 upon 3. So minus 7 upon 3 over here. The reduced form. Okay, and now I'll multiply the numerator with 5. Because here I multiplied with 2, 2, 3, 3, 4, 4 and now with 5, 5. Okay, so now you tell me. 7 5 is 35. So 35 upon 5 3 is 15. Minus remains as it is. Don't forget the minus sign. This is my fifth rational number. This numbers at the top I have mentioned just for the explanation. So don't write these numbers, this 1, 2, 3, 4, 5. Okay, at the end of the solution you have to just write with the commas, separated with commas. Minus 7 upon 3, comma, minus 14 upon 6, comma, minus 21 upon 9, comma, minus 28 upon 12, comma, minus 35 upon 15. These are our 5 rational numbers. Please do it, students. Students, now the next question. The main question remains same. Give 5 rational numbers equivalent to the given rational number. So we need to write more 5 rational numbers which are equal to or same to or equivalent to the given rational number. So the first thing, students, what I will do is I will write the question once again. Minus 111 upon 117. I can clearly see over here, students, that this number, both numerator and denominator, does not goes in 2 times table, because here 1 is an odd number, 7 is also an odd number. Okay, so let's check with our method whether they goes in 3 times table or not. 1 plus 1 is 2, 2 plus 1 is 3, 3 goes in 3 times table. That means 111 will go in 3 times table. Similarly, 1 plus 1 is 2, 2 plus 7 is 9, and 9 goes in 3 times table. So 117 will definitely go in 3 times table. So now let's start. I'll say 3 3s are 9. It's 11 here. So remaining 2 carry. 3 7s are 21. Then down here I'll write 3 3s are 9. 2 carry. 3 9s are 27. Don't forget this minus sign. So minus 37 upon 39. And I cannot reduce it further. This is the least what I can do. The reduced form, I will say. 37 itself is a prime number, so I cannot reduce it further. So minus 37 upon 39 is the reduced form of minus 111 upon 117. So our first step is get the reduced form. That's it. Can I say, student, this my reduced form is my first rational number which is equivalent to my question? Yes, I got my first one. Now every time I'll do it, I'll start with the help of this reduced form. So let's start, students, now. Okay, now for the second one, once again I'll just copy first this reduced one. Minus 37 upon 39. And what I will do is I will multiply the numerator with 2 and denominator with 2. Okay, from the reduced form. Always start, the first step is bring the reduced form and just always start all your numbers with the reduced form. First time multiply 2 2, second time multiply 3 3, third time multiply 4 4, and so on. So okay, so if I multiply 37 with 2 now, so what will be the answer? Let's do it. 2 sevens are 14, carry over 1. 2 threes are 6 plus 1 7. Don't forget this minus sign. Upon 2 nines are 18, carry over 1. 2 threes are 6 plus 1 7. So answer is minus 74 upon 78. This is my second rational number, which is equivalent to my original thing. Okay, now let's do it for the third rational number. Once again, I'll start with the reduced form, minus 37 upon 39. So minus 37 upon 39. Okay, now what I have to do? Earlier case I multiplied 2 2, so now I'll multiply 3 3. Understanding, students? Okay, now what will be the case? You all tell me. 3 sevens are, it's 21, carry over 2. 3 threes are 9, 10 11. Upon 3 nines are 27, carry 2. 3 threes are 9, 10 11. Students, if you observe, when I multiplied numerator and denominator by 3, I got the original question, minus 111 upon 117. Now this we cannot serve as an answer because this was the question. So we got this, but this we will be not counting in our 5 more rational numbers, because this was the original question and they told us to write more 5 rational numbers which is equivalent to this. Okay, which are equivalent to this. So now this will not be counted in a 5. Once again, let's continue with the reduced form. Our reduced form is minus 37 upon 39. Minus 37 upon 39. Okay, now I multiplied first with 2 2, then 3 3, and now I'll do it by 4 4 4. Okay, with 4 4. Let's do it now. 4 sevens are 28, carry over 2. 4 threes are 12, 13 14. Don't forget minus sign. Upon 4 nines are 36, carry over 3 here. 4 threes are 12, and 12 plus 3 is 15. So I got my answer as minus 148 upon 156. And yes, I can term this as my third rational number. Yes, students, let's do it. Okay, now comes for the fourth rational number. Let's once again start with this reduced one. I can say minus 37. You can do it simultaneously. Minus 37 upon 39. Okay, now what to do? First I multiplied 2 2, then 3 3, then 4 4, then I'll do it by 5 5. Okay, 5 sevens are 35, carry over 3. 5 threes are 15, and plus 3, 185. Okay, upon, don't forget this minus sign. 5 nines are 45, carry over 4. 5 threes are 15, 15 plus 4 is 19. So it comes to 195, students, and this will serve as my fourth rational number. Okay, now I want the fifth one also. Let's start once again with the reduced form. I have minus 37 upon 39. First I multiplied by 2 2, then 3 3, then 4 4, then 5 5, and now comes the time for 6 6. Okay, I'm multiplying numerator with 6 and denominator also 6 in my submind. You can write these numbers, this 2 2, 3 3, 4 4 with pencil in your exams also. No need to erase it afterwards. Okay, students. So now what will be the case? 6 sevens are 42, comes here 4. 6 threes are 18. 18 plus 4 is 22. Okay, don't forget this minus sign. Upon 6 nines are 54, carry over 5. 6 threes are 18. 18 plus 5 is 23. So 234. So students, now this will act as my fifth rational number. So students, at the end of this question, you will mention this, that minus 37 upon 39, then minus 74 upon 78, then minus 111 upon 117, then minus 148 upon 156, then minus 185 upon 195, then minus 222 upon 234 are our required rational numbers.